Hello everyone, my name is Tauqir Nasir and I am PhD candidate in Institute Mediterranean University, Northern Cyprus, Turkey. Today I'm going to present my paper which is about the prediction of properties of friction steel spot welded joint of aluminium 7075-T651 with Ti6 aluminum 4 vanadium by using machine learning algorithms. Let me share my screen with you. So why we have to use the machine learning? Machine learning has been applied in many fields, like it has been applied in medical applications. It has been applied in forecasting the weather environments. Now, researchers recently being applying this machine learning into manufacturing as well. So the idea of mine was to use these machine learning algorithms in welding as well. So we can predict the surface quality of the weld. We can use machine learning to optimize the process parameter. We can use machine learning to predict the response, like outcomes of the uh, results before doing the application. Because as we know that doing an experiment is very expensive and time costing and this. So before doing experiment, we need to apply the machine learning techniques to predict the process parameters and then apply those parameters. So now we are applying these machine learning algorithms. We will discuss it here. The content of this is machine learnings, branches of machine learning, the learning system models, training and testing model, performance evaluation, and summary. As we know, artificial machine learning is the sub branch of artificial intelligence. And artificial intelligence is a technique which enables the machines to mimic human intelligence. And the machine learning is a method where we use statistical methods that enable machines to learn tasks from data without explicitly programming them. Machine learning, various conventional and non-conventional optimization methods are available. Conventional methods use random numbers initially to look for optimum solution through stepwise iteration, and non-conventional method use statistical and probabilistic approach. Machine learning has two techniques, that is supervised learning and unsupervised learning. So supervised learning is classification and regressions, where we have to use the classification techniques. And in this study, we use the regression techniques, where will be the linear regressions, SVR, and others. So we'll discuss there. So machine learning problems, we can use the discrete problem solutions and we use the continuous solution problem. So in this study, we have used the regression techniques. Supervised machine learning, the four methods have been applied here: artificial neural network, adaptive neural inference system, support vector machine, and regression analysis. The training data that have been used, it has 18 sample sets, which is the input parameter, that is dwell time and the evolving or rotational speed, and the output parameter is the tensile shear strength. Each parameter is a 3-time replicate. Artificial neural network has the ability, like human systems, which can learn from experience. So as you can see, the structure of the ANN neural network, it has input layer where we give the revolving speed and dwell time as input parameters, and hidden layer it trained by themselves and then predict the output results. So at the right side, you can see this is the training models and validation and testing models, and we can see the prediction properties like training the capacity of the model, that is R value is 0.99 above all conditions. Adaptive neural fuzzy inference system, it is a combination of artificial neural network and fuzzy inference systems, where it has a combination of both if-then rules. and it has used those techniques and then learn from it and then apply. It has 5 layers. First, the fuzzification layer. Fuzzification layer is is a membership function of input and input and output variables. The second is the product layer, which calculate the firing strength of the input parameters, and normalization layer that calculate the firing strength of each tool. And the layer 4 is diffusification layer, which weighted the value of the each nodes and calculate them. And the fifth one is the output that we get it. And this is the MFS structure, working structures, which we use on MATLAB. So all these tools have been used in MATLAB. The third is the sport vector machine. Sport vector machine is developed in 1990 as a nonlinear solution for classification and regression tasks. SVM reduced the structural error. SVM used the quadratic optimization techniques to avoid the local minimum. Larger the margin, lower will be the error of the classifier. SVM transformed the solving problem into quadratic problem, which makes solution unique and global optimal. This is the pictures of the sport vector classifier and the sport vector regression. So the larger will be the distance between these lines. In case of classifier, the better will be the results. But in case of regressions, we use only those values which will be between these margin layers to train the model. And these are the results of the SVM results. Here we have used 2 techniques, that is the fine Gaussian and the medium Gaussians. And it is optimized, as you can see, it has given the linear interpretations. The fourth is the regression analysis. Regression like determination is most frequently used classical estimation method to examine the combination between the relevant and irrelevant value. The relationship among the input variables and predictive variables can be described by using a linear and nonlinear model equation. Multiple parametric regression models, which implies the static and machine learning techniques to develop these results. For example, linear, generalized, and nonlinear regression model. And this is the mathematical model of the regression analysis. And you can see the picture of that, where we have a tensile shear load, regression speed, revolving speed, and dwell time. Mathematical models, here we can see the values, and T represent the dwell time, R represent the regression speed. And the prediction outcomes of these results, we can see this, we have a dwell time and regression speed, and the prediction and the evaluation of this prediction results was based on the prediction error, like minimum prediction error, and the root mean square value. The better will be the consider the results. So in this result, we can see the SVM error has minimum, that is 1.82 and 2.354. The rest of them it has a higher prediction error rate. So on the end of the summary, I can say that the SVM regression model provided better prediction compared to NFIS and ANN models. In SVM, we use 2 kernel functions of fine and medium Gaussian provided better forecast results in terms of error prediction and root mean square value. Minimum prediction error was 2.354 and 1.822 with root mean square value of 67.762 and 56.25. It shows that the prediction capability of SVM model is much higher than ANN and NFIS in this current research. Comparatively, the regression analysis shows lower prediction error compared to the NFIS and ANN. In current results, ANN and NFIS has lower performance than other models. These are the reference paper where the data is used. Thank you for your interest. Thank you.